We have what we call four measurable properties of gases. First is volume, wherein its units can be expressed in liter, milliliter, or cubic meter. Second is temperature, wherein its unit should always be expressed in Kelvin. Third is amount of gas, wherein its unit can be expressed in mole or millimole. And fourth is pressure, wherein the standard pressure is defined as the atmospheric pressure at sea level, wherein it is equal to 1 atmosphere and is also equivalent to the following units of pressure: 101.325 kilopascals, 760 millimeter of mercury, 76 centimeter of mercury, 29.9 inches of mercury, 760 torr, or 14.7 pounds per square inch. It was Robert Boyle who experimented on the relationship between pressure and volume of a gas at constant temperature and amount of gas, and formulated what we call Boyle's Law, which states that the pressure of a gas is inversely proportional to its volume at constant temperature and amount of gas. This means that as the volume increases, its pressure decreases, or as its volume decreases, its pressure increases, which can be expressed in symbols as pressure is inversely proportional to its volume, wherein at constant temperature and amount of substance. Expressing this mathematically, this becomes pressure is equal to a constant over volume. Simplifying, this becomes pressure times volume is a constant, or Boyle's law therefore can be expressed as P1 V1 is equal to P2 V2. We will now be using this formula to solve problems involving Boyle's law. Let us now apply the formula in solving the following sample problems, starting with number 1. A 10.0 cubic meter gas exerts a pressure of 1.5 atmosphere. What will be its new pressure if its volume is increased by 3.0 cubic meter? To solve the problem, you are going to write all the given information and what is the unknown. So this will be condition 1, or the first condition, and this will be the second condition. For P1, it's 1.5 atmosphere and its volume is 10.0 cubic meter, and its pressure is unknown, and then its volume is increased by 3. So meaning to say we are going to add 3 to the initial volume, which will become 13 meter cube, or 13 cubic meter. Using the formula for Boyle's law, P1 V1 is equal to P2 V2, and then substitute all the values to the formula. This becomes 1.5 atmosphere times 10.0 cubic meter is equal to, the pressure is unknown, times 13 cubic meter. Transpose this value to the other side so that the unknown will remain on this side of the equation symbol. So this becomes divided by 13 cubic meter. Also divide this by 13 cubic meter. So this becomes 1. Pressure, therefore, is equal to, using your calculator, 1.5 times 10 divided by 13 will give you 1.2 atmosphere. Let us proceed to problem number 2. A weather balloon containing 30.0 liters of helium gas at 90.0 kilopascals is released and rises. Assuming that temperature and amount of gas are constant, determine its new volume when the atmospheric pressure has reduced to 40.0 kilopascals. To solve the problem, we are going to write all the information given in the problem, starting with pressure number 1, which is 90.0 kilopascals, and its initial volume is 30.0 liters. And then its pressure 2 will be 40.0 kilopascals. And its volume 2 will be unknown. So writing the formula for Boyle's Law, P1 V1 is equal to P2 V2. Then substitute all the given values to the formula. So this becomes 90.0 kilopascals times 30.0 liters is equal to 40.0 kilopascals times V2. Transposing these values to the other side of the equation symbol, this will be divided by 40.0 kilopascals. Divide this also by the same value, 40.0 kilopascals. So this unit cancels with this one. This one becomes 1. What will remain here will be V2. And the remaining unit will be liters. So using your calculator, 90 times 30 divided by 40 will give us a value of 67.5 liters. Let's try problem number 3. A 1,250 milliliter sample of oxygen gas at a pressure of 12.0 pounds per square inch is transferred to a 2,750 milliliter container at the same temperature. What will be its new pressure in millimeter of mercury? To solve the problem, we are going to write all the information given by the problem. Starting with volume 1, it's 1,250 250 milliliter. And pressure 1 will be 12.0 pounds per square inch. And its volume 2 is 2,750 milliliter, and the pressure is unknown. Writing the formula for Boyle's Law, P1 V1 is equal to P2 V2. And then substitute all the given information to the formula. So this will become 12.0 pounds per square inch times 1,250 milliliters is equal to pressure is unknown times 2,750 milliliter. Transpose this value to the other side, so this will be divided by 2,750 milliliter. Divide this also by the same value, 2,750 milliliters. So this unit will be cancelled, okay, and this will become 1. So pressure, second condition, therefore, will be equal to, okay, the remaining unit is pounds per square inch. And using your calculator, 12 times 1,250 divided by 2,750 will give us a value of 5.45 pounds per square inch. But this is not the desired unit. According to the problem, we are going to express our answer in millimeter of mercury. So that means we are going to use a conversion factor in here. So at the bottom will be pounds per square inch, and on top will be millimeter of mercury, the relationship of which is 760 millimeter of mercury is equivalent to 14.7 pounds per square inch. So cancel this unit. What will remain will be millimeter of mercury, wherein, using your calculator again, 5.45 times 760 divided by 14.7 will give us a value of 282 millimeter of mercury. So that's it. Thank you for watching, and please subscribe now.